Hi, this is Kevin Hunter with SOS. The purpose of this video is to give a quick overview of the QBE Pro print software. I am not going to go into detail on every little tiny bit because there are some great help functions that are available just by simply scrolling over each of the commands. It does give you a little more detail, as well as tells you can press F1 for help at any time. This software is pretty intuitive, but I do want to share with you just a few little tips that we have found useful here at SOS from using the software for over a couple of years. The first thing I will tell you, when you open up the software, if it tells you there's an updated version available on QBEFI.com, please take a minute and go download that. A lot of times what we've seen with the close to a dozen software updates is little glitches are corrected or little issues are corrected, so definitely worth keeping it up to speed there. If at any time you do download a software update and you're having problems, you can always revert back to the previous version, but I have not found any major issues with regards to updating it all, so definitely take advantage of that. The first thing, when you open up the software, you'll notice a QBE Pro 3D system software. Now, if it's the very first time you've ever opened it, you will see a screen like this pop up first. Essentially what it's doing is asking you, what is the machine that you're using? Is it a QBE Pro or is it any other version? It'll ask you how many jets do you have. Now, the key with that is if you bought a QBE Pro, that's a single. QBE Duo, that's 2. QBE Trio, that's 3. So you can simply put in the number of jets. Where that becomes important is it'll be options that you'll be able to select colors, jets, all these other wonderful things when you get into the software. The next thing, depending on the number of jets you select, you will tell the software what material is in Jet 1, Jet 2, or Jet 3. Now, this is just a simply drag down list. It gives you all the colors that are available. Once we get neon, or excuse me, not neon, once nylon is available, I do expect to see a nylon options here, but right now, just all of your ABS colors and all of your PLA colors. So I've selected white, which is in our machine here at SOS, but any color you select there, will be corresponding when we get into the print driver software. But once you configure that, then the software open and you'll be to your home screen here. Now what I've done is gone ahead and open up an STL file, but let me show you how you do that. Pretty simple. If it's a single file, you just go over and select Open Model. And once you hit Open Model, it's just a matter of finding where your STL files are. So anywhere you've got them saved on your hard drive, you're just opening up STL files. So once you get that open, this is just a file named Earring that I opened. It will actually appear here on your build plate. The gray area here is representative of the build area that's available on the QBE Pro. So gives you a good representation of what you got to work with here. So Open Model opens your STL file or your other build or your other design file, whether it come from SolidWorks, FreeCAD, AutoCAD, SketchUp, whatever it may be. It is by default looking for STL files, and you can see that by right here. It's asking you where are the STL files. Your other option is your creation models. That would be the files that have been created in other types of software. Don't see those quite as often. The STL files are essentially your standard format for 3D printing. So those are the ones that we typically see. Your open model assembly is exactly what it says there. If you have multiple parts that are a part of a build, then that's where you would go there. Essentially what the software does is bring in one model, gets it all situated, and then goes back and says, okay, where's the second piece, where's the third piece, and each step along the way is asking you, is there another piece, and you just simply say yes. Close and close all, pretty much self-explanatory. If you want to close a particular file, you just simply click on it and hit close, or if you want to close everything on the build plate, you just simply hit close all. And then you also have a function that is save as, and what that does is allow you to save this particular STL file. If you've changed the orientation, if you've changed the size, you've changed anything about it that we'll talk about here in a second, you have the ability to save it. Now right here is a single color option. If you do have a multiple color machine, but you only want to load models in a single color, then you make sure that box is checked. Otherwise, what will come in is any color information that is a part of the build file will come into this setup. Most of the time when STL files come in, they're all white. There's no color information, but you have the ability to go in and set color that's in the machine. So I'll show you that in just a minute. Then coming across a duplicate model, if you just wanted to duplicate, make two of, make multiple copies of, fill up the build plate with, you have the ability to just duplicate a model. So, you simply select it, make sure that it's selected, and then you just come in and click duplicate model. And what happens is it actually goes in. It's the same thing as you would run into when you're opening the assembly. Depending on the size of the file, the complexity of file, anything like that, you may have a little bit of a longer time when it's actually opening up the file. But when you're duplicating, it essentially gives you the ability to place multiples of these around the page, or excuse me, around the build plate, so you'll be able to print multiple ones at the same time. So now you can see where instead of just 2 earrings, now there's 4. So pretty simple process there. And you can rotate the build plate so you can see the different things going on there. But that's essentially your duplicate model. Now your move on your X and your Y axis, you have the ability to put in increments. You can put in 1 to 100. And what it'll actually do is move the models on the X or Y axis. So that's horizontal or vertical, anywhere on the build plate. You have the ability to move them in steps, or you can actually change those steps where if you wanted to change it to 25 or whatever, you'd have the ability to move it. Not a feature that I see a tremendous amount of use on, because you also have this button called Auto Place. And what Auto Place does is puts the model on the build plate so that it prints as fast as possible using the settings that you've set in the machine. So Auto Place typically overrides any of the move or X or Y for most of our customers there. Coming on over your scale geometry, you have the ability to enlarge or shrink files, which is kind of a neat feature, particularly our customers in the education market. If you have the ability to maybe use or access a 3D printer when you're teaching geometry, for instance. Let's say we wanted to talk about the height of a three-dimensional object. Well, instead of having to redesign a file from scratch, I can actually enlarge it 150% just by simply highlighting, type in 150, hit scale, and it actually goes up. Or I can shrink it. I can go down to 50% and actually scale it down as well. I can convert from inches to millimeters or millimeters to inch. That's important. Sometimes when you bring a file in, you may not know what the scale of it is. You may not know if it's inches or millimeters. So when you pull it in, you're thinking inches, and it turns out it is so small on the build plate, and you're like, wow, that must be a different measurement. You have the ability to just simply go in and convert it to millimeters or to inches, however you see fit. The next one is pretty useful. We see quite a few folks that actually go in and use the scale or rotate geometry. And the reason for that is you have the ability to turn things on their side. You can actually rotate objects. You can go in and change the entire object if you wanted to, just by simply pressing the Z. I can rotate things on the Z axis. I can rotate things on the Y axis. I can rotate things on the X axis. So any of the axes you have the ability to rotate. Now the question usually I get is, well, why would I do that? Well, it depends. If you're trying to get more objects on the build plate, if you're trying to see if it prints better in one direction or the next, you can lay things down on their side where sometimes it'll use less supports. There's a variety of reasons there. I encourage folks to play around with it because it is a pretty powerful tool, particularly when you get things that have a flat edge. So if you can print with the flat edge laying down on the build plate, you have a much better chance of getting a higher quality print as opposed to printing things on angles or having to use supports, because this machine does use supports when it goes and prints, and sometimes those can be a bit of a challenge to remove depending on the orientation. So as your familiarity with the product goes up, you'll be able to see which orientation really works best for you. But you can change those at any time. Now, one button I did want to point out on both the scale geometry as well as the rotate geometry is the revert button. The revert button allows you to go in and basically undo everything. So if you do not have, let's say you made a change and it ends up being something that you didn't want to do, then you have the ability to revert back and do something else. So it gives you a little flexibility there. Then your last one is where your colors would come into play. So if we have multiple jets on our machine, we would have different colors set up here. So right now all I have is just print jet 1 is set to white. If I had it set to black, this will be black, and these will be different colors. You have the ability to click on a model and actually change the color if you had different colors here. So pretty neat stuff there. The next button is your build button. That's the one that we're going to spend the most time on. But before we dive in, I just wanted to give you a quick overview. Over here to the side, it gives you the size of the model that is selected. So if you don't have a model selected, it obviously will be blank over here. But right now, we've got this model selected, and it's telling us what the size of it is in X, Y, and Z axis. Tells us what the position is on the plate, so we've moved it around a little bit. It tells us what the printer configuration is. We obviously have ABS white there. So that's always a quick little reference to tell you how big something is. But let's dive into the build area. This will be our main section that we talk about. Essentially what I'm doing is I'm taking an STL file to bring it into the software so I can view it, scale it, rotate it, any other things, duplicate it. But then once I've got it all set the way I want it, I go into my build file and I say, okay, let's build this. Now, when I dive into my build file, you got a couple of things that really pop out to you initially. The first one being your layer resolution. You've got 70 microns, 200 microns, and 300 microns. Now, the QBE or the QBE Pro software gives you some tips on it. If you just simply hover over it, it'll tell you what the differences are. The 70 micron level is what I use when I have either really small parts or I have parts that have a tremendous amount of surface detail. That's where I would use a 70 micron. Now, the 200 micron is the default. That's essentially just the normal mode. That's where you get a nice compromise between speed and detail, so it gives you a good overview of it. And then your 300 micron is where a lot of our middle school, elementary school, even some of our high schools use the machine because you don't get as much detail. You get good enough, but you also use less material and it prints faster. So sometimes that's a good compromise to be able to give you a little higher output speed without making too many sacrifices on it. Essentially, a good rule of thumb is if you have something that's a tremendous amount of detail and you're planning on using it a long time, stick with the 70 micron. If it's something that has a very short shelf life or something that is you're not sure if it's the final product or not, it's going to be a version, then 300 microns will be good. And then the compromise, of course, is the 200 micron. Now, moving over to the next one is your print strength. That's where you get into hollow, strong, and almost solid. It's exactly what it says. If you hover over it, it's the fastest way to produce is a hollow mode because it keeps everything internally. It prints the outer surfaces as thin as possible. It does a larger pattern for spacing inside. It's best for parts that aren't under a lot of stress or pressure or going to be bending, handled a lot. Again, short life expectancy, average life expectancy, and something that you need to be really more durable and solid would come out here. So your best scenario for getting layer resolution of quality 70 micron, making it the strongest that you possibly could, would be your almost solid. And then the last one is your print pattern. Your lines is going to be fastest way to print. Your diamonds, as it explicitly says here, it's going to be strong print pattern with two directional cross bracing. So think about you've got cross bracing one way for a deck. This is essentially doing it two different directions. So it gives you your fastest but not quite as strong for your print pattern, a little bit stronger, more of what I use for our standard is a diamond. And then your honeycomb pattern, which gives you three directional cross bracing. What that essentially means is it's going to make it as strong as possible. It does slow it down a little, but if you're looking to get your highest quality, your strongest print strength, and your tightest pattern to make it last the longest is 70 microns, almost solid, with a honeycomb pattern. So that gives you a quick overview of that. We're going to jump into some of the settings here in just a moment as well. But I wanted to talk a little bit about rafts and support. Support material is what the machine uses when it has overhangs or it has internal structures that don't have a lot of meat to them, a lot of thickness, so it has to use a support internally so the machine can build, because as it's building, it's doing layer upon layer upon layer. So anything that maybe starts out with a small base and flares out to a much larger top, you need supports underneath there to keep it from warping, keep it from falling down as it's being printed. If you have multiple colors in the machine, you can go in and select a different color for your support. Now, the reason that's important is because it makes it much easier to remove. So let's say I'm printing my model in white, but my supports are in green. Well, when the model is finished, I'll be able to clearly see my supports and more easily remove those. So much, much easier to work with. Now, your support type is you can either do points. As you can see, it choose the support to part interface geometry. So if you've got very fine details that are touching each other or very close to each other, then a point support type will give you a little more detail to be able to do that. The majority of the supports that we use internally here are the lines. So it gives you a little more emphasis on the support. It uses a little more material. But what it does is make the support removal a little bit easier by using the lines. Now, you've also got your sidewalk material. What your sidewalk material is exactly like above. You can choose whether it be white or whatever other color is in there. And I'm going to talk about sidewalk and what it is in just a moment here. But before we dive into the advanced button, I wanted to show the different print modes. You've got standard, premium, and draft mode, as well as custom. Now, standard mode is a preset print pattern. So if I hit standard, you can see pretty much it goes 200 microns, strong, diamonds, and uses line and ABS for my support material. I can also go in and select premium, and what premium does is just bumps it up to a 70 micron level, and then my draft mode goes in and selects it to 300 micron level, leaves it at strong, but then uses a line pattern. So it's got some presets in there that'll allow you to make some changes real quick. But then when you also get into your custom mode, that allows you to make whatever changes you want that fit your application. Now, the biggest question I usually get is, well, what's the best way to do it? What's the best print setting? That's a difficult question to answer because, quality and output is in the eye of the beholder. What I tell everyone is take one model, make it about an inch or two higher in z-axis, that's in height, and print it using different settings. And leave that model out so that you will have a visual of what the different settings show you. Something I've done in the past is actually print an Eiffel Tower model that I got off of, I think, GrabCAD or Thingiverse or one of those sites out there. But what that does is allow me to print it in different setups so that I can see what the changes are and what they make. So that's a real easy tip to go in there. But let me talk a little bit about the Advanced tab. When I click the Advanced tab, it gives you some different settings that you can go into. Now, I will tell you the majority of our customers, they probably play around with this more than they need to. The standard settings on the machine or the custom settings that allows you from the first window really do a good job of letting you go in and make some basic changes for the QBE Pro. But for our more advanced users, I do want to go through this a little bit. So your print pattern fill spacing allows you to change in millimeters from down to 1 all the way up to 20. And you can see the increments that are in there are very, very small. You saw the majority of the time I leave mine on 5. Now, how I've determined that is, again, I took that same Eiffel Tower pattern and I printed it on multiple different settings here to figure out which one I thought was best. I came to the conclusion that the 5mm fill spacing worked best. Moving down to the shell options, you've got 3 choices here. You've got top surface layers, bottom surface layers, and outer walls. The top surface layers are actually the very highest point of the model. So if you want those to be a little stronger, you can move those up to 20, or you can move those down to 3. 14 seems to have been a nice compromise. Again, it's going to be a little bit dependent on your model. What I have seen, if you have a tremendous amount of detail all the way up to the highest point of your model, it's better to keep that top surface layer a little bit higher than maybe in the center here. So it gives you the options. Again, there is no, this is the best one. The best one is going to depend on what your model is. It's going to depend on what your preferences are. Coming to the next one, the bottom surface layers. Now, when you're printing, particularly in ABS plastic, as it's cooling, it actually can pop off the build plate a little bit on you, so you have to be careful there. Now, the natural tendency is if you're experiencing any kind of material coming loose from the bottom of the build plate, what folks have a tendency to do is I'm going to jack up that bottom surface layer, so I'm actually putting more material down on the bottom of the model. Now, on one side of logic, that makes sense. You would think you put down more material, it would hold firm, right? Actually, turns out the opposite is true. When you put down more material, it's putting down exactly that, more material on that bottom layer. And what happens as it cools, that bottom layer has a tendency to start popping off the plate. So what you will see is as you turn that down, you actually don't lose detail. You're just putting a little bit thinner layers on that bottom, so you have less of a tendency of it to curl or to pop up off of the plate. Again, it's one of those that you just have to find a preference of what works best for you. The next one is your outer walls. You can see right there, again, when you hover over it, it'll tell you exactly what it is. The outer walls, it just sets the number of all outside part borders for a part to a custom number of borders. Sounds real impressive and all that other fun stuff, right? But essentially what it is how thick do you want your outer walls? Do you want them really super thin, or do you want them a little bit thicker? What I have found is that kind of middle compromise between 5 and 6 really works well for what I typically print on the cube machines. Again, it'll be one of those things that if you get into it and start making settings, just make sure you remember what settings you did. That way when you analyze your model or you're taking a look at it, and particularly when you're comparing it, you'll be able to see what the differences are. Okay, so your next one, your support borders. This one is actually kind of the opposite of what you would think. If I disable my support borders, then it makes it much easier to clean the supports away. If I have my support borders on, then what it'll have is actually more material used for the supports, and it makes it a little bit more difficult to remove. So a good default setting is just to disable your support borders. Now, coming on over your draw fine lines and enable for best fine detail on parts. I've got some folks that swear by this. They think they turn it on when they have an extremely small model, and it does a tremendous amount better. I personally have tried it both on and off and have not seen a dramatic discernible difference. But again, qualities in your eyes, you make that determination. Now, your next one you come into is your sidewalk options. What a sidewalk is essentially the bottom layer of your print model will have a sidewalk around it of perforated material. What it does is give you more surface area to adhere to the build plate, so you've got less chance of it actually popping up off of the plate or warping. Particularly comes in handy when you're doing two things. One, printing in ABS because it has a tendency to cool a little quicker. But more importantly, when you're printing a very large object that takes up a lot of the build plate, you need to have a you need to have a sidewalk down first so that it will actually adhere the bottom of that model much better to the build plate. The sidewalk also makes it much easier to remove your model when you're finished printing. So with the sidewalk, you've got a few things in here that you can take a look at and you can adjust. The first one is your distance. It sets the distance that the sidewalk extends from the border of the part. So right now it's set to 0, so that means the sidewalk would just be underneath the part. But what I typically do is I'll come in here and set it to 4 or 5. What that does is give me a 4 or 5 millimeter extension beyond the part so that I can see my sidewalk as being placed down. Now, the number of layers for the sidewalk, that's how thick you want it. You obviously never want it at 0. So I bump it up to no more than 3. And what that does is the first 3 layers that are printed are sidewalk material. That typically gives it enough surface area to be able to adhere down to the build plate. Then your offset, basically what it says there, it sets the distance the sidewalk extends from the actual model so that you can go in and easily remove it. Extends out from the intersecting base of the part border to a custom set. So if I want that to offset 0.4, I can go in and do it. This is an expression of millimeters, so you can take it down to 0.15 to 0.4. Don't overanalyze this area, because if you look at a ruler, the difference in 0.15 millimeters versus 0.4 millimeters is actually very, very small. Then your sidewalk perforation, I always leave that on because it makes removing the sidewalk much, much easier. So it makes it like a perforated piece of paper, makes it easy to tear off there. Your support angle is essentially what it is. You can take it up from an 89-degree angle all the way down to a 1. And what that is it actually lets you go in and make some adjustments there that will make it easier to see, or anything that has that angle. So if I got it set at 10, for instance, anything with a 10-degree angle of overhang or more or less, I will have a support put in place. You can bump that all the way down to a 1, all the way up to an 89. So again, it's one of those things. What is the proper setting? Really going to depend on what you're doing. I have learned that between a 10 and 15 works for me. But again, it'll be one of those things you have to print a few files and then see what happens. Once you've got all your settings done here, there's 2 things. One, when you're finished, you just simply hit OK and it'll save them. But before you do, if you're playing around with it and you're trying to figure out different settings, you want to look at them, see where they are, make adjustments, all that, and you go, oh man, I just want to get it back to where it was, you can, this is your favorite button here, is Restore Defaults. It goes back and just takes away all the changes you made and puts it back at the default setting. That's a great button to always remember. You're never stuck. You can always hit Restore Defaults. But then once you're done, you can just hit OK, and what will happen is your Advanced tab will turn yellow, and that tells you, hey, you've made some changes, and the changes are now stored in this file. Now, once I've got all my settings set the way I want, I just simply hit my build file, and what that does is it actually takes this file and it'll convert it over to an actual build file. Now, the difference with a build file versus a design file is a build file is what is sent over to the QBE Pro. The design file is what is actually brought into the software. So you can see what pops up is it's going to save it as a QBE Pro build file now. You can change the name of it to whatever you want, and then when you hit save, it actually saves it to where you've told it. And I've already saved this file, so I'm going to cancel out of it, but real important step, make sure you save the file in a place that you can find it. Now, if you're going to take it over to the printer on a USB stick, your USB stick or D drive would be located here. You can save your build file straight to the USB stick, so you can take it over to the machine. But any place you save it, it will save it as a QBE Pro build file. That's a mouthful there. QBE Pro build file, and that'll be the file that you actually print. But I'll cancel here, and that is pretty much an overview of how to create a build file from an STL file. So now that we've created a build file, I wanted to share with everyone a couple of little things about some more advanced features of the QBE Pro print software. This software will give you the ability to preview a build file. What I've done is gone ahead and open up a build file that was created by one of our customers. It's a layout of a house. So what had happened is they actually designed this in one of the rendering softwares, whether it be AutoCAD or Revit or SolidWorks or whatever it may be. So they designed that file, and now what you're seeing, it looks a little bit different. It may, at first glance, you think, well, that looks a little hazy. No, actually what it is it's the layers of the build file. So all I did was simply go over here. This close button will actually be open. So I opened a print file, which you see here, and then this is what opened here. So a couple of important things it's showing you. It's showing you that the layer thickness is 0.07 millimeters. That is 7 micron. That is the finest resolution you can do. So extremely detailed here. Gives you an idea of the mass. That's the amount of material that will be used in order to create this file. It's 140.74 grams. So pretty significant file here, as well as the estimated time to print. You can see that estimated time to print is 32 minutes. So significant file. This would be a great example of starting a file on Friday afternoon before you leave, and then you come in Monday morning and voila, you got this great house file that you printed. But the key thing I wanted to show you here was this slide on this side. This slide, as you take it down, you'll see the layers of the file actually go down. Now what this is showing you is the layer upon layer that the actual QBE Pro will be printing. So your bottom layer starts here, and then as you move up, you can see the process that the machine goes through to create the file, to create the model. So think of this as a great print preview. This print preview will allow you to see the differences in the model that you've made with the various settings within the print screen, within the build screen, excuse me. So for instance, if you created this model in a 70 micron level, you save it as a build file, you'll be able to preview it here, and then you go back and change it to a 300 micron level, and you'll be able to see the difference. You'll also be able to see the time to print, how much mass is there, and you'll see the layer thickness that you change. So think of this as a fantastic print preview that you can use. Now, one really neat thing with this is you can actually zoom in. So I can zoom in to a much tighter view and still go through the print preview, so I'm able to see the details a little bit better as I go through them there. Where this comes in handy when I'm printing something that has a tremendous amount of detail and I am trying to make sure that the corners are all straight and it's going to print the way I wanted it to print, then what I do is actually go in here and do a print preview or just slide the scale on a build file. It allows me to see how the model actually comes to life and how it will be printed by the machine. So for instance, if I did a preview of this and it was at 70 micron level and I said, man, 32 minutes is just way too long, I want to change something. I'm going to change it over to 200 micron level and see what the time difference. Most likely you're going to cut off about 20% of the build time, so significant difference in the amount of time here. But before I go to print, I can actually do a preview and I'll be able to slide up and down the scale to see the difference, what it makes in my model. Most of the time you're going to be able to determine that changing the layer thickness on most of your models does not make that big of a difference. So I encourage everyone to use this. It's a great educational tool for those of you that are teaching people how to do 3D printing or how to get familiar with 3D printing. It's a great educational tool to be able to show them. It's also a great tool to give you an estimate of time to print, quality of print, lets you see the difference in the various changes within the build software, to where you can change layers, change wall thickness, change all those various items that we talked about earlier in the video, and it keeps you from having to print everything. You can just preview everything. So that's a good overview of a little more advanced feature within the QBE Pro build software. But on behalf of SOS, we appreciate you taking a few minutes to look over this video. If there's any detailed questions or any more info you need, feel free to reach out to us by calling 888-914-7476, or you can visit us at sos.works, or feel free to reach out to me directly. My name is Kevin, and I'm the owner of the company. I'll be glad to help you with anything that you can think of with the 3D printing. We look forward to continue to working with you and all of our customers, and we look forward to pushing the boundaries of 3D printing. Thank you so much. Have a great day.